it's Presley at ActOutGames.com here, and today we're going to be doing a thingy. Yes.
Yeah, so it's a cold...
scale, some water, some measurements, that's what it's called, and some other stuff.
Yeah, so it's a cold, snowy day here. Stuck in the house a little bit, so another good day for some science experiments. I thought it'd be cool to talk a little bit about displacement.
Yes.
And volume and mass and all those good things.
Yes.
All right? So,
just in case you need to know what we have this float, a bolt, a broken car light bulb, another screw thing, some water, some of these little zombies,
and
some cups and nothing.
We measured most of these things and made, before the vlog, made a little list of weights of all of the different things that we're going to be experimenting with, so we can refer back to this as we're taking a look at this. Presley, on one of my trips long ago, I got her a little Troika doll set that's all little zombies.
That's how you pronounce that?
Yeah, and it actually all kind of turned out really, this guy turned out perfect.
I thought they were even called Russian dolls.
Yeah, Russian nesting dolls, yeah. So this guy, who's one of the nesting dolls, hollow inside, turned out to be a perfect thing to experiment with this. I was going to use like a hollow Easter egg, but I couldn't find one.
We have a lot of those.
Yeah, I couldn't find one of them. So, but this guy worked out really well. So this is really easy stuff to do at home. Then it's kind of a cool little experiment, and we'll talk about Archimedes like we were going to talk about before. And so I'll tell you the Archimedes problem again, and then as we go through all of this, you can see if you can figure out how he solved it.
Because I think I learned about it, but then I forgot.
Well, I told you what the problem was, but we never talked about solving it. The king had a crown. There's two different versions of this that I've heard. And he gave some gold to a jeweler to make a crown. And the jeweler came back and gave him a crown. And the king was worried either that he didn't use all of the gold that the king gave him, and he was worried that he cut some of the gold out and made the crown out of less gold than he gave him in the first place, or that he mixed the gold with some other metal, and that it wasn't pure gold. And so he, the crown was kind of irregular shape. Like if you have a ball, it's easy to know how much material is in that ball. Or if you have like a cube or a normal shape, a geometric shape that you think of like squares and circles and triangles and pyramids and stuff like that. But it was really irregular shape, so they couldn't figure out how to determine how much material was in it. They knew how much gold they gave the guy, but they couldn't tell how much gold was in the crown to see if it was the same amount, because it was kind of irregular shape. So Archimedes had to try and figure it out.
Like a shirt.
A shirt?
Yeah, like a shirt.
Like a shirt. It'd be hard to figure out the volume of a shirt.
Why would you make a shirt?
Yeah, shirt would be kind of hard.
Yeah.
But so what we're going to do here is we're going to talk about volume and mass and density, primarily are the things.
Well, none of the things we have in this room are very irregularly shaped. They're like made out of squares and stuff.
Well, yeah, but I mean, it wouldn't be easy because it's got all these ridges on it, right, on the screw to like calculate all of the volume of those things. This guy's kind of irregularly shaped.
Kind of.
He's not perfect spheres and stuff. So it would be hard to calculate the volume of this guy, right? Let's talk about what these three things are first, okay? So you can draw a little triangle. I kind of like this. Maybe I'll put something up on the screen that shows this. At the top is mass. And then in the bottom corners, you've got density and volume. Like that, right? And so you can think of it like if you want to figure out what volume is, you could cover up volume and it's mass divided by density, right? And you make this little pyramid, and when you cover up the one that you want,
there's mass going on here.
And since these are beside each other, you multiply them. But basically what it is volume is how much space something takes up, right? So this takes up a decent amount of space, but because it's hollow, a lot of that space is just air, right? It's empty. So density is how much stuff is in a little bit of that thing, right? So like this, a tiny little sliver of this, the same size of a sliver of this has more density because there's more stuff in it, right? The molecules are all packed together, whereas this is mostly air, right? And then volume is just how much space the whole thing takes up. Like the volume of this is bigger than the volume of this, right? Even though this weighs more and it's denser, this has more volume because it's just physically bigger. It takes up more space. Does that all make sense? You're cool with that? All right. So So those are the things that are going to come into play here while we're messing around, right? And we have this little cup of water that we measured out to be exactly 150 milliliters of water. And what we're going to do is we're going to play around with a couple of things and see what floats and what doesn't float and why it does or doesn't float. Okay, so let's take. So for example, when I measured the bulb, was it?
I think the bolt.
Let's measure the float, right?
Yep.
So when I weighed this float out,
Yep.
it weighed.
It was rolling away.
It weighed in at 4 grams.
Yep.
3 or 4, yeah, it's kind of staying right around there.
It's in between. It's kind of light. That's why it floats. It's really, really light.
So you said this floats because it weighs 4 grams.
Yeah,
and it's really light, and that's why it floats. And if we put this in a cup of water, you can see on the video, it does float. You're absolutely right, it floats. So if it floats...
Why would it be called a float if it didn't float, number one?
If it floats because it's light and it weighs 4 grams, this screw weighs 3 grams. It weighs less than that float. So is this going to float? Since it weighs less?
Well,
since it's light?
Actually, no, but this has a less volume. More volume. Or less volume. Less volume.
More volume in this.
Well, more volume in this.
Huh?
Because, well, it has a bunch of air pockets in here.
It has a bunch of air pockets in it, right?
So that makes it float.
So it's not how much it weighs that makes it
Yes.
float, is what you're saying.
It's also really light.
So before you said it was really light, and that's why it floats. But this is lighter, and it sinks right to the bottom, right?
It's because it has, like, no, it doesn't have that much mass in here.
Well, they have, like, weight is a good measurement of mass. So this weighs more, so it actually has more mass than this does.
Yes.
Right?
It's bigger, but it does have air pockets in it that make it float.
It's much less dense.
Yes, however,
right?
this one doesn't.
Right. So
This is a screw.
let's look at, let me see, let me make sure that didn't change. Yeah, so we're still about 150 milliliters. So do you think this guy floats or sinks when he's hollow like
He's
that?
hollow. He probably would float. But
Okay, put him in there.
Oh, yeah.
Okay, so he does float. So this guy's volume, he floats, but what do you think happens if I put this in him?
What in here? What did you put in here?
I put the big bolt in him.
Oh, okay.
What's he going to do now?
He's probably going to sink.
You think he's going to sink? How come?
Because that took up some of the volume. My hands are moving. That took up some of the volume, and that thing doesn't have that much volume, so it sinks.
It made it more what?
More. What is it called? Dense?
More dense. That's right. It's more dense because it has more stuff in it. It has exactly the same volume. Like if this little guy takes up exactly the same amount of space that he did before,
yes.
right? But there's more stuff in there now, so he's much more dense. And so you're right. When I put him in here, now he sinks because he's more dense.
It's attempting to float.
Now, something else that we want to talk about is, so you see it's 150 milliliters of water right now. When I put this guy in there and he sinks, what do you think is going to happen to the water level? Does it stay the same? Does it go up? Does it go down?
It goes up.
It goes up. Why does it go up?
I do not know. I just know that it does go up.
It goes up because of a thing called displacement.
Displacement.
So this thing...
I think I knew what that was, but then I forgot.
When this thing sinks, it's going to displace water. It moves water out of the way.
Yes, that's what it was.
Right?
That's what it was.
So
now I know what it was.
It has to move the exact amount of water that it takes up out of the way. So when I put him in there, the water is going to go up by the volume of this guy. So this tells us the volume of this. Watch. Let's see where it goes. So it's at 150 milliliters right now. If I put it in there right now, where does it go to?
Where did it just go?
So it goes to 150, 60, 165 milliliters maybe?
Maybe I cannot tell.
So this is what we're going to do.
I think one of those lines was on 1.
Yeah, they're 10. So look out. So what we're going to do is we're going to measure and see
65.
the water that it moved. We're going to see how much that water weighs.
Yeah.
The water that it moved out of the way. So we're going to use this pipette. And basically I'm going to pull water out of here until it goes back to 150. Because that's where it was before, right? Lean back a little bit. Okay, so that's 150, right?
Right.
So that's back to 150. So all of the water that is in this pipette now, right, is water that was displaced by that guy.
Yeah.
Right? So this water should be the same volume as him. That water should take up the same amount of space that he takes up. So let's put that water in here.
If you didn't do it long notice. 7 grams. And it takes up 17 grams. So you did this
Huh?
It takes up 17 grams.
17 grams, right? So that is, so the water that he displaced is 17 grams.
Yes.
Right? And so how much does the bolt weigh?
It weighs 17 grams.
And how much does the boy weigh?
7.
So how much are they together? We've got them put together right now, so how much weight is that?
So that would be that would be I'm thinking.
It's okay.
24.
24 grams, right? So the thing that we put in the water weighs 24 grams, and it displaced 17 grams worth of water. So it weighs more than the water that it displaced.
Yes.
And so what does that mean?
The water is less dense.
Right, but that means it sinks.
Yes.
Because it weighs more than the water it displaced, so it sinks. So let's take him out again.
Oh, no, this
Put this water back.
And also, one of the reasons why that is because water is made out of air, so it's kind of it's less dense.
It means that the water is less dense, yes, because it weighs more. The same volume, we agreed that the volume of water I took out was exactly the same as the volume of water the volume that this took up. And since this weighed more, and the same volume weighed more, it's more dense. That means it's more dense by definition. So now I took the screw out, or the bolt out, so now I just have the buoy. So how much does the buoy weigh?
7 grams.
7 grams, and we've already measured it to see how much water he displaces. He displaces 17 grams worth of water, right? So the water he displaces weighs more than he does. So what does that mean?
He floats.
He floats. We put it in there. So, how would you use what we just looked at to solve Archimedes' problem?
I would put it, well, I'll tell you float and sink. Well, yeah.
But the first thing that we did, though, was measured how much volume was in the buoy, right? It was like 15 milliliters of water was the same volume as this guy. So if Archimedes took the crown and put it in water and measured how much the water rose, then he would know exactly how much volume was in the crown. And then he could figure out how much gold would weigh, that same amount of gold would weigh, and compare it to the crown. And so, like, if he put the crown in water and found the amount of water that it would be, like, let's say it was 15 milliliters it was a tiny crown. Okay. It was 15 milliliters of gold.
It was this on his head.
So he took 15 milliliters of gold and weighed it. He knew it was gold and he weighed it. And then he took the crown and he weighed it, and the crown was lighter. Then he knew that it was less, right? Or he knew that he had mixed it with a lighter material than gold, so he could kind of compare. So that's how you can measure the volume of something using this. But what happens, like I said, is that in order for something to float...
That's why he did it in the bathtub.
Well, so what happened was, the story is that he got in the bathtub, and when he sat in the bathtub, he saw the water rise on the side of the tub. And no one had really paid any attention to that before, and he didn't know why it happened. And when he started thinking about why the water rose when he got in the tub, he discovered displacement, and he realized that he could use that to solve the king's problem, and he got all excited, and what did he do?
He ran outside naked screaming something.
Eureka.
Eureka.
Yeah, which means I found it.
Yes.
So yeah, he ran down the street naked screaming Eureka, is the story. And he solved the king's problem, I suppose. And no one knows, it's funny because it's a very famous story about him having this problem to figure out if the crown was real or not, if it had used all the gold or not.
But no one knows.
But nobody knows what the answer was. Like nobody in the story, when you hear it and people talk about it, nobody says, and he found out that the guy stole gold from the king until the king had him killed, or he found out that the guy really used all that. Nobody knows what the answer came out to be. But it's a famous problem for how to use displacement, right?
But
and
nobody knows the answer to it.
Here's one other really cool thing that I wanted to show you that deals with displacement. So this guy, do you think him by himself, without the top on, will float or sink?
I believe it will sink, but it is kind of a boat.
We'll just set it up there, yeah.
Yeah, it floats.
So it floats. So
This is a boat.
what's happening here, though, look, so there's no water inside. So he's still taking up all the space, that he took up before, the water is still being displaced by the whole thing. But if you push him under a little bit and let water get inside, what happens?
He sinks.
He sinks.
Yeah.
Why does he sink?
Because he just got more dense.
He got more dense. Well, there's water, but he's taking up a lot less space, right? When he's just floating and the water is just up to the edge here, he's holding all of this water back. But when the water can go all around, it's just how thick the walls are. It's just this tiny little piece. So like here, let's put this guy back in there one more time. So if we put him in complete and we sink him, he goes up to about, we said 165, right? 165 milliliters. If I crack him in half, so I'm still putting the same thing in there, but I'm letting it fill up with water. How much did the water go up?
No, it didn't go.
It just barely went up, right?
Yeah.
So there's a lot less volume if you let the water in. So you're right, though. That's how a boat works. Is that a boat can be super heavy, like an aircraft carrier or something like that, right? It's like millions of tons.
Our boat
right?
in Assassin's Creed.
The big ship in Assassin's Creed, that's right. The reason they float, though, is because of the way that they're shaped, is that they displace a lot of water. They spread that weight out over a huge amount of volume. And so as long as they displace more water, if the water that they displace weighs more than they do, they float.
Poppy's boat has a little V shape in the back.
Yeah, that's exactly why they're shaped, so that they displace more water, right? But that's also why a boat will sink when the water comes in, because when the water comes in, they don't.
Everyone freaks out when they have a leak in their boat.
That's right. That's why Poppy's boat, when it started to leak in the back, was a problem, because it wasn't displacing all of that water. The water was sort of coming back in, right? Which was a really cool thing. One thing that we didn't do here that I want to show you, which I think is another cool thing. Get all this stuff out, and I keep taking a little bit of water out as I do this, so we'll reweigh to make sure we're all still good here. So let's reset the scale.
No, that is not part of the scale. Oh, no, it's not. Okay.
So 158.
If you left it off, this would become part of the scale.
Right. This guy is going to float when I put him in. He doesn't have the bolt inside of him, right? He's going to float, and he weighs 7 grams.
Yes.
Right? So when I put him in the water and he's floating in the water, how much is the scale going to say?
How much is the scale going to say? It's going to say...
When he's floating. He's not on the bottom, he's floating on the top of the water.
Would that say, 169?
Wait, he weighs 7.
7. Oh. I think so. Why am I doing that hard? So it's 8, it's 15. So you would do 65.
So you think it's going to go up to 165? Even though he's not touching the bottom?
Yep. That's
exactly right. So even though he's floating on top of the water's still holding his weight, right? It's still holding him up. So you still add the weight, just like if he had sunk to the bottom and was sitting there. So
this went before.
His weight does.
His weight changes.
His weight applies directly to the scale, right? So that's a good guess. You're absolutely right. And it's the same thing. Like the other thing that you can think about this is in air. Air behaves a lot like a fluid, so it's kind of the same way. If you take a balloon and the balloon, it doesn't have any air in it, it's just kind of compressed, it sits on the ground, right? Because it's taking up so much volume and it's the air that it's displacing, it weighs more than that, so it sits on the ground. But when you blow it up with helium, now it's displacing air the same way that a boat displaces water. And if the air... And that guy is, right. If the balloon displaces air that weighs more than the balloon does.
If the air displaces the
balloon floats. Right?
It would be funny if with the air displacing the balloon would be like all weird shaped. It would be like a balloon animal every time.
So that's kind of cool, huh?
Right.
That a balloon, it works like a boat. It's displacing air, and if the air weighs more,
it's like way smaller.
There's, big balloons, like hot air balloons.
Yeah.
And that's exactly how they work, too.
A balloon that you would be talking about, that is. Right now, you're talking about, that would be way smaller than a boat.
But it's the same thing.
Yes,
the
same
principle.
thing.
The principle is the same, right? It doesn't change. So displacement is still why that works.
Yes.
And the other thing, like this, where this is floating in the water, but at the same time, the weight still shows up on the scale. That same thing happens with things that are floating in the air or flying, right? So a helicopter or an airplane, when an airplane is flying overhead and it's in the air, its weight is still coming down to the ground. It's just being spread out over a really long area, right?
Yes.
So it's not weightless, right? So that plane flying over our house is really still pushing down on the house with some force.
At least it's not like so hard that when a plane flies over your head, you just go. It feels actually heavy, but it's not that heavy.
Right. Well, it is that heavy. It just spreads out over a large area.
Yeah. So it's not going to be.
It's not that heavy in one spot.
Yeah.
Right.
No, it is that heavy, but it's not that heavy.
The same weight as if it were sitting on the ground and parked is still being put into the ground. It's just being spread out over a long space. It's kind of cool that to think about airplanes and helicopters and stuff like that are still putting weight on the earth as they fly over. They're just spreading it out over a really huge area, so you can't feel it when it happens. So that's displacement. That's how displacement works. Things float or they sink based on what? What determines if something floats?
Displacement.
How?
If it displaces how much the water if it's less than how much water it displaces, it floats. If it is more, then it sinks.
That's right. That's pretty much all there is to it.
Yep.
Right. That's how you can tell if something will sink or will float.
Yes.
And so that's why shape matters. Because if the shape is designed to displace a lot of water, it's more likely to float, like this. So the good example that we had were these two things, right? So let's take him out. So these weigh roughly the same thing, right? The screw is actually a little bit lighter.
Yeah, it's a little bit lighter.
But this is the shape of this float is designed to displace a lot of water. And this is not. This is designed to be very compact, right? And that's why even though they weigh the same, one floats and one sinks. Because of the shape and the volume that's taken up by that bobber. That's cool, yeah? Yeah. Okay. Anything else?
Not really.
Okay. John, 8 to 10.
Bye.